Hello everyone, and welcome to today's video. I'll be dealing with questions from worksheet 12, which will be covering mainly complex numbers. I know that most of you guys didn't really deal with complex numbers in your tests, so it might be a bit overwhelming, especially as you prepare for the exam. So I decided to just put together this small video dealing with a few of the problems from worksheet 12, just that you can use in preparation for your exam. Right. So let's have a look at the first question, which is asking us to find the roots of the equation z squared equal to 1 plus root 3i. And to do this, we'll be using de Moivre's theorem, right? Which, if you have a look at your notes, we'll be using what's called in your notes the second theorem. That's the theorem for the roots of an equation. So it says that if you have an equation of the form z to the n equal to r cos theta plus I sine theta, that's in the general form, which you can write as well as r theta. If you're looking for the roots of that equation, which we'll call k, those roots are just equal to r to the 1 over n, and the angle will just be theta plus k minus 1 times 2 pi all over n, and being the exponent of the of z in the equation, right? And k will go from 1 all the way to wherever n ends. So n will really tell you how many roots you're looking for. So if n is equal to 2, that means that you're looking for 2 roots, right? Okay, so let's apply this to this problem and see where we go. So first we need to find what is r and what is theta. So we know that r is just equal to the square root of x squared plus y squared, right? And from our problem, x is equal to 1, so that's just 1 squared, and y is equal to root 3, which is just root 3 squared. And that just gives us r is equal to root of 4, which is equal to 2. Okay, so then theta is equal to tan inverse of y over x, which is equal to tan inverse of root 3 over 1. So now, what is theta? Well, we know that both x and y are positive. That means that the sine and the cosine of the angle are both positive. And that's the case for the first quadrant. So our angle is in the first quadrant. So now, what angle in the first quadrant has a tan of root 3? Now, if you go through the motions, you'll figure out that that angle is just pi over 3, right? So what does that mean for our roots? Well, our first root, which is z1, will be r to the 1 over 2, right? Remember the formula? R to the 1 over 2, and the angle would just be theta, which we found to be pi over 3, plus k, which for the first root is equal to 1, so that means 1 minus 1 times 2 pi, which is 0, all divided by 2. And this would just be equal, therefore, to r, which is just 2, so that's root 2, and the angle pi over 6, which, if you write this down in the polar form, will just give you root 2 multiplied by cos of pi over 6 plus I sine of pi over 6, which is just equal to root 2 multiplied by cos of pi over 6, which is equal to root 3 over 2, plus I times 1 over 2, which is equal to root 3 over root 2 plus root 2 over 2i. So that's our first root. Our second root is equal to, once again, root 2, because all roots have the same value of r. So second root will be root 2, and the angle would just be pi over 6, sorry, not pi over 6, but pi over 3, plus k minus 1, k is equal to 2, so that's 2 minus 1, that's 1 times 2 pi, so 2 pi, all divided by 2, which is equal to root 2 multiplied, well, really root 2 with the angle being 7 pi over 6. And that is just equal to root 2 multiplied by cos of 7 pi over 6 plus I sine of 7 pi over 6, which is equal to root 2 multiplied by negative root 3 over 2 minus I over 2, which is equal to root 3, negative root 3 over root 2 minus root 2 over 2i. So that's our z2, second root. And if you look at these two roots, that means that b is our answer in this case. Okay, so that is how you would find the two roots that we are asked to find here. You are free to pause the video at any point and just go through the question yourself and check if you get the same answer. Looking at the second question, we are asked to find, well, to express really this the equation in polar coordinates. So two things. Well, we know that in for polar coordinates, x is just equal to r cos theta, y is equal to r sine theta. But we don't have r and we don't have theta. Okay, we need to find r. Theta will vary, but the radius will stay the same. How do we know that? Well, we know that this equation that's given to us, if you go back to your conic sections, you'll notice that this equation is in fact a circle, right? Because you can rewrite it as x squared plus y squared plus 6y plus 9 minus 9. So you can try to complete the square there, and you find x squared plus y plus 3 squared is equal to 9, which is the equation of a circle with radius equal to root of 9, which is just 3, and center being equal to 0 minus 3. Those are the coordinates of the center, right? So we have the radius. Now let's substitute our expressions into the equation. We know r is x is equal to r cos, so that would be r cos squared, squared, yes, plus r sine theta squared plus 6 times r sine theta is equal to 0, which is equivalent to r is 3, so 9 cos squared theta plus 9 sine squared theta plus 18 sine theta, which is equal to 0. And that will just give us, if we simplify further, 9 multiplied into cos squared plus sine squared theta plus 18 sine theta is equal to 0. Alright, Now we know that cos squared plus sine squared is 1. So you have 9 plus 18 sine theta is equal to 0, which is the equation in polar coordinates. Right? So that's that.